Okay, guys and girls, we have finished all the new information for Unit 8. It's been a whole lot of information, and you've learned it all without me there with you. We're just doing the best we can under the circumstances. I've had very few questions from students. I don't know if any of you have been using Miss Whitney Allen's virtual tutoring or not. That is available. But we do have a test over this unit coming up on Monday, and that test must be completed in Schoology. All of your grades from the time we started these NTI days forward are on Schoology work. So if you're behind, you need to be going back and trying to finish some of that stuff up. If you get it all finished, if you do all the work, I promise you, you can't fail. So when you do this test on Monday, you're going to be home. Use your online calculator as needed. If you checked out a TI, use that as needed. Use your notes. Use this study guide. Those are the tools you have available right now, and you just have to use the tools that you have. So we're going to consider this an open notes, open all of your resources test, do your own work, but use the resources that you have. Let me remind you, some of you haven't figured this out yet, that the answer keys to all of the worksheets are in the unit folders. So if you want answers to Unit 8 worksheets, you go look in the Unit 8 folder, and there are scans of all the answer keys. You should be checking your daily work. And if you're not getting correct answers, then it's time to start asking some questions or go back and check some work. Okay, so test on Monday. You have this really big study guide at the end of your Unit 8 packet. And the page numbers are not at the bottom of these pages because it was an add-on. I normally keep this separate. So I think probably a good thing to start with is number those pages starting with 19. And the next page would be 20 and 21 and 22. I didn't do this before I handed it to you. That last Friday that we were in school was just crazy. 23. And I was rushing around all day trying to get papers photocopied, and 24 is the last one. And trying to get everything in your hands that would get you through at least to spring break. So at this point in time, I'm just operating under the assumption that I'm not going to get any papers anytime soon. I don't know that I want any papers anytime soon. And so continue to do the daily quizzes on Schoology. Here's a hint, guys. Those daily quizzes on Schoology, check your work first on the answer keys, and you can't miss them. You get all 5 out of 5 right every single day if you'll check that work on the scans of the answer keys first. So those are easy daily grades if you take the time. And then all you really have to worry about pressure on is tests, because you don't have answer keys to those. Okay, so what I like to do for this is go back to the beginning of the unit and do a couple of problems from each section of the study guide. And we'll do the first half today, and we'll do the second half tomorrow. Some of this information you've not seen since a couple of weeks, before spring break, so it's a little rusty. I'll do a couple of practice problems, and then you go back and work some practice problems in each of these sections. And more practice, the better. So you might do half of them now. You might go back and work on half of them over the weekend. But you do definitely need to do the practice so that you're ready for the test on Monday. So with that being said, we'll start in the first section of the study guide, and you can just ride along with me on your hard copies. And we're going to simplify radicals. First thing we learned was Pythagorean theorem, and simplifying radicals was one of the skills that we had to have. So for simplifying radicals, we need to factor. So I want to factor 90. So I've got a couple of options for how to do that. I could factor it by hand. I could factor it using a tree. So 90, I'm going to go over here to the side. I can break that up as 9 times 10. And then 9 is 3 times 3, and 10 is 2 times 5. Those are all prime factors. So I'm going to rewrite square root of 90 as square root of 3 times 3 times 2 times 5. 3 times 3 times 2 times 5. And the order of those factors really doesn't matter. Now if you have an Inspire, we'll do a quick refresher of a nifty little tool you have here. If you're on a calculator screen and you go to menu, scoot that up just a smidgen. If you go to menu and option 3, which is algebra, oh, wrong one, option 2, number. One of your options is to factor. Number 3 is factor. And if you type in your number to be factored, 90, and press enter, it's going to give you 2 times 2 threes, so 2 times 3 times 3 times 5. It's in a different order, but it'll work just as well. So this will give you a little extra help, especially if you have a larger number to factor. Okay, you don't have that trick on the downloadable or the online graphing calculator. The online, actually, I guess it's a scientific calculator that I've uploaded for you, the link for. But you could probably, if you're clever, go to Google factor tool, and you could probably find a tool that will factor for you. So this is, oh, what are we doing? We're looking for pairs. We're going to go fish. So we got a pair of threes, and pairs come outside to the front of the radical. So this pair of threes comes outside as a 3. A pair on the inside is equal to 1 3 on the outside. And then we have a radical with a 2 times 5 left inside. Now, at that point in time, you could go ahead and multiply those back together to make a 10, or you could make it a separate step of multiplying them back together to equal a 10. So 3 radical 10 is your correct simplified form. Okay. Let's get down to number 12 in the same section. The only difference here is we have an extra factor in front of the radical. All you're going to do is keep up with it. So we're going to start by factoring inside the radical, just like we did on number 1. So I need to factor 490. If I have a factoring tool on a calculator, I could go ahead and go straight to that prime factorization. Otherwise, I need to factor this by hand. If it ends in 0, it'll multiply by 10. So this is 49 times 10. 49 will only factor as 7 times 7, and 10 will factor as 2 times 5. 7, 2, and 5 are all prime numbers, so we're finished with the factoring. So let's write down what we have to work with. We have a 2 outside the radical, and then we have 7 times 2 times 5 inside the radical. I have a pair of 7s in the radical that we're going to fish out. And so on the outside we have the 2 that was already there times, everything's multiplication. There's understood multiplication between the 2 and the square root of 490. The 7s came out as a single 7. And then we bring along our radical with a 2 times 5 inside. There's no pairs there. And then we multiply factors together. 2 times 7 is 14. 2 times 5 is 10. So our final answer is 14. Oop, I lost my 1 there. Times the square root of 10. So factor, fish out the pairs, and then put factors back together if you can. Okay, so that will take care of that entire first section. Go back and practice those other 10 problems. Plenty of practice to work on. Okay, so we'll move into the next section that we studied, which was the Pythagorean theorem. So in Pythagorean theorem world, you know 2 sides and you're solving for the third missing side. That's how you know to use a squared plus b squared equals c squared. The a and the b make the L. They make the right angle. So you always make sure that you identify which 2 sides those are before you start substituting numbers in. Now, there are 3 different things that could happen with Pythagorean theorem. You could solve it and get a whole number, in which case you have a Pythagorean triple, and there might be a shortcut for that one. You could solve it and get a decimal approximation. That's reasonable for lots of real-world applications. You could factor it and have to leave your answer in this form that we just reviewed, this simplest radical form. So you'll need to watch your directions to see what's going on, what kind of answer you're going to need. So the first thing I want to do is review some triples. And I'm going to have to scoot that over. Okay, so I gave you a list of triples on that first set of 8 OneNotes. And these are common sets of 3 sides that make right triangles. 3, 4, 5, by far the most famous. 5, 12, 13. 8, 15, 17. 7, 24, 25 are the 4 most commonly seen in textbooks, on standardized tests, in study of trigonometry. They just pop up a lot. And we like these because they're shortcuts for solving. We don't have to do any actual work to solve. So for this first example, number 13, we want to find the missing side. And I notice I have a leg of 5 and a hypotenuse of 13. Well, that's this triple right here. A leg of 5 and a hypotenuse, which is always the biggest, is 13, means the other leg has to be 12. So if it's a triple, we don't have any work to do at all. We just know that that's 12 kilometers. So that's one method, is to memorize your triples and use those. If you miss the fact that it's a triple, you could set it up and solve it the long way. That will always work. And so if we need to solve it the long way, then we want to first make sure we know where our 2 legs are. So the right angle's here. So 5 is a leg and x is a leg. So I'm going to say x squared plus 5 squared on the left side of the equation. Hypotenuse is 13, square it, and then I would solve for x. So we'll square what can be squared. So 5 squared is 25. 13 squared is 169. You have squaring keys on your calculators that you could use, or you could just do 13 times 13. That will also work. We're going to subtract 25 from each side. Minus 25, minus 25. And that's going to leave x squared equals 144. And then we need the square to go away, so we're going to do the inverse operation. That's a square root. And the square root of x squared is just x. Those will cancel each other. And then the square root of 144, if I type that in the calculator, it's a nice whole number, 12. So you could solve it the long way, but if you know a triple, it's going to save you all this work. The triples are definitely worth the trouble. Okay, so then we get to number 14. And I see a 6 and a 10, and I don't see that in this list. But now, if you're clever, you might note that there's still a triple hiding in there. Because if you multiply any of these triples by any constant, you can make another triple. So if I take, say, this first triple of 3, 4, 5, and I multiply it by 2, it makes a 6, 8, 10. So this is a 6, 8, 10 triangle. So you can make another triple. Another way you can solve this is to do it the long way. A third way is you can look for a common factor of 6 and 10. And that common factor is 2. Think of this as 2 times 3. Think of this as 2 times 5. And the 3 and the 5 are part of the 3, 4, 5 triple. So we need the 2 times the third member of the triple, 4, or 8, to give us the third side. We'll do number 17, and then we'll finish this section. So a 16 and a 20, they aren't in this list. Oh, I'm going to have to scoop my paper. Sorry, number 17. 16 and 20, they're not in that list. Nowhere in the list. But 16 and 20 have a common factor. The greatest common factor of 16 and 20 is 4. 16 is 4 times 4. 20 is 4 times 5. and I see lurking here the non-common multiple 4 and 5. 5 is the hypotenuse. Oh, that's a 3, 4, 5 triple again. So that means this side has to be 4 times the other member of the triple. I'm missing the 3, and I've got my colors goofed up here. Missing the 3, and so 3 is the missing member of the triple. And if we put 4 times 3 together, we get 12 inches for this third side of the triangle. So if you can fish out the triples, that's going to save you work every single time. Otherwise, you can always work it out the long way. And this entire section has triples in it. Okay, so you're going to finish fishing for triples or practicing in section 13 through 18. Okay, let's flip over that page and go to page 20. We have more Pythagorean theorem problems, but I get to number 19 and I realize pretty immediately that these are not triples because those are not whole numbers. If you don't have whole numbers, you have to do it the long way. You have to use the theorem. So let's find legs of number 19. The two legs make the right angle. So 7.3 and 12.6 are the two legs. So those get added together on the left side of the equation. So 7.3 squared plus 12.6 squared equals x squared as our setup. Now, I can actually do that entire number crunching on the left side in one step. If I have this calculator or even the Desmos calculator, it will make it look just like this. They both look really pretty. So 7.3 squared. And if you can't find your square key, it's right beside the 4. You can barely see it right there. And then plus 12.6 squared. And that is 212.05. And then we'll bring down the equals x squared. Having trouble keeping my paper where it belongs this evening. Okay, so now I need the square to go away, so I'm going to take the square root of both sides. And the square root of 212.05, you have a square root key that works exactly the same way on the online calculator. You can also use that. And that's approximately 14 point. The directions said to round to the nearest tenth if necessary. So 14.6, if we round up, is equal to x. So about 14.6 feet is our final answer. Alright, skipping on down to the next section. We have find the missing side and leave your answers in simplest radical form. So this is exactly the same work we did the last two problems, working it out the long way, because obviously that's not a triple, because that is not a whole number. So let's do the long way. Set up the Pythagorean theorem. So we have a leg here, and we have a leg here. And those two sides get added together. So x squared plus 15 squared equals, the third side is square root of 257 squared. So we're not going to panic with that square root. You treat it just like any other number. Let's square each side, or square the individuals. 15 squared, I can do that with the calculator and get 225. And on the right side, we get a lucky break on this one because squares and square roots cancel each other. So that just leaves us with a 257. We don't even need a calculator for that part. Okay, we need the 225 to move to the other side, so the x squared is on the side by itself. So subtract 225, subtract 225 on each side. And x squared is equal to 32. And then we take the square root of both sides. And we don't get a pretty whole number on this one. Square root of 32 is 5 point something ugly. And that's not an option for the answer on this one because it says leave your answers in simplest radical form. Okay, that means I got to factor it. So before I bring down this last step, I'm going to have to factor the 32. So I'm probably going to go do that work over in the margin because it keeps this work from getting quite so messy. I'm going to find a spot over here at the side and I'm going to factor 32. 32 is 16 times 2. 16 is 4 times 4. Oh, 2's done. Each of these 4's gives me 2 more 2's. So I end up with 1, 2, 3, 4, 5 2's, or 2 to the 5th power. So this is the square root of 2 times 2 times 2 times 2 times 2. Pair them up. Go fish. Pair of 2's, bring a 2 outside, times pair of 2's comes out, bring another 2 outside. So each of these pairs gives you 1 2 in front of the radical. There's one lonely 2 left over in the radical. And if we put this 2 times 2 back together, we get a 4 radical 2. So I'm going to come back over here and write in 4 radical 2. That's my final answer. Stick some meters on the end. So the actual solving of the equation is the same work you did in the other problems. The only difference is you have to use the factoring to put the final answer in simplest radical form. So you have that extra step to do on these. Okay, so everything through problem number 30 has those same instructions. So that's a lot of Pythagorean theorem information, but that's all related. All of that page front and back is totally related. That leaves us with the third page of the study guide. That'll get us halfway through this section. So this is the number 31 through 40 section. And this is the section I'm a little more worried about because special right triangles are kind of the oddballs of the bunch, and we've not seen these for a while. It's been since well before spring break since we've done these. So the first thing we need to review are the actual 2 special right triangles. Now you're supposed to have them memorized. Hello, this is an open notes test. So if you had to look them up, you could look them up this time. If you're in class, you would have to have them memorized. Okay, but you have to at least know that they exist so you know to go get them and use them. So when you see problems like this one, they have a 45 and a 90 degree angle and only one side is known and you have to find missing sides, that's not a Pythagorean theorem question because you don't already know 2 sides. That's not a Pythagorean theorem question. You don't already know 2 sides. That's not a Pythagorean theorem question. You do not already know 2 sides. This entire section is about using your special right triangles, and you have 2 of them. So let's go up here and jot them down. So the first of the 2 special cases, which we haven't seen for a while, was the 45 degree, 90 degree right triangle. This is in your notes. And if you've lost your notes, there are scans of those notes in the Unit 8 folder in Schoology. The legs are 1 and 1. Those are in a 1-to-1 ratio. In other words, they're always the same length. And the hypotenuse is always square root of 2 times bigger. So if we had legs that were 5 and 5, the hypotenuse would be 5 times the square root of 2. If we had legs that were 20 and 20, the hypotenuse would be 20 times the square root of 2. So you can scale this up or down to make new triangles. The other special right triangle is the 30, 60, 90. This is what we form when we take half of an equilateral triangle. And the sharp corner is always 30. And then we have a 60 degree corner and then a 90 degree corner. And it's really important when you draw this one that the side opposite the 30-degree angle is the shortest one. It's the short leg. It's always 1. The hypotenuse across from the right angle is the longest side. It's 2. And the side opposite the 60-degree angle is radical 3. And we learned why that was using the Pythagorean theorem when we did the lesson on section 8.2. So you can go back to your 8-2 notes for this section. Everything up until then, at 1 through 30, is all from section 1 notes. Okay? 8.1 notes. So you can scale this triangle up and down just like you can the 45, 45, 90. So if you have a short leg of 5, that means you'd have a hypotenuse of 10 and a long leg of 5 times radical 3. So whatever you multiply one side by, you multiply all 3 sides by that same constant. So some of you are savvy enough that you can use that trick of just making every side 5 times bigger, 7 times bigger, 20 times bigger, and not have to actually show any work on this. Some of us will need to work it out, and you just do what you need to do. So I'm going to show you the long way to work it out for those of you who can't just see it. Okay? So let's pick maybe about 3 questions to do together, and then I'll leave the rest for you to practice. So number 31, I see a 45 and a 90, which means this third angle has to be a 45. Okay, that means it is similar to this 45, 45, 90 triangle right over here. So I'm going to redraw this one beside this one, but I'm going to turn it around the same orientation as this one is. So I'm going to rearrange it so that the right angle is in the upper right hand corner, just like this one, and the 45-degree angles are in the same position. And then when I turn that around, I have to take the sides with it. So the 2 legs are both 1s, and the hypotenuse is radical 2. Now, if you're pretty savvy, you might look at this and say, the one that I'm given is 6 times bigger than this blue one, so make everything 6 times bigger. So V would be 6, and U would be 6 times radical 2. If you can do that, write down your answers and you're finished. Otherwise, you may need to write proportions. So we're going to write a couple of proportions to solve for the missing sides. So we'll start with V. V is to 1. V is to 1 as, and then I need a pair of sides with numbers. 6 is to 1. Those are corresponding parts. 6 is to 1. And then I cross multiply. So V times 1 in this direction is V. 1 times 6 in this direction is 6. Okay, we're finished with V. V is equal to 6. Just really quick to set up and solve. Okay, now we're going to solve for U. So I need a different pair. So U is to radical 2. Those are corresponding parts. U is to radical 2 as, and then I need another pair of parts. So I'm going to reuse 6 is to 1. 6 is to 1. Cross multiply. U times 1 is U. Radical 2 times 6 is 6 times radical 2. U is on a side by itself. We are finished. So there's our final answer. So redraw the reference triangle with the same angles, and then set up proportions and solve. Okay, let's skip to number 34. So for number 34, we have a 30, 60, 90 triangle. Because I see a 30 and a 90, that means the third angle must be a 60. It's the only possibility. So that matches this one. So I'm going to use this one as a reference triangle to compare to this one to make an equation. So I'm going to redraw this one beside the one that's already there. And I'm going to turn it around so that the right angle is in the same bottom left right hand position. 60 degrees is in the bottom left, 30 is at the top. Angles go in first, make sure those angles are in the same position. So opposite the 30 is where the 1 should go, that's your shortest side. Hypotenuse is 2, always opposite the right angle. And then the long leg is radical 3. That's the middle-sized side. Radical 3, if you do a decimal approximation, is bigger than 1 but smaller than 2. So it's the middle-sized length. Now, you got a couple choices. If you're savvy, you might look at this and say, the triangle on the left is twice as big as the one on the right. So double 1 and get a 2 here. Double the radical 3 and get a 2 radical 3 here. And you're finished. No work to write down. If you have trouble seeing that, it's time to set it up. So pick a variable to solve for. So how about m? M is to radical 3. So we drew it so that those are in corresponding positions. M is to radical 3 as 4 is to 2. 4 is to 2. Alright, let's cross multiply. M times 2 is 2m. 4 times radical 3 is 4 radical 3. Now, this one requires an extra step because m is not yet on a side by itself. So we're going to need to divide by 2. Divide by 2. Those 2's will cancel. Leaves us with m on the left. And on the right, 2 will divide the 2 and the 4. 2 divides 2 one time. 2 divides 4 two times. So it leaves us a 2 times radical 3 in the numerator. And the denominator has an understood 1, which we can just drop. So m is 2 times radical 3. Let's repeat the process and solve for n. So n is to 1. We're going to squeeze this one over here. N is to 1 as, and I'm going to use 4 is to 2 again. 4 is to 2. Cross multiply. N times 2 is 2n. Equals 1 times 4, which is 4. We will divide both sides by 2 and get n equals 4 divided by 2 is 2. N is done. All of these problems in the section 31 through 40 are essentially the same as these. If you can do them just by looking at them, fantastic. If you need to set them up, you're going to need to set up and solve proportions. Okay? Alright, so that covers the first 2 of the 3 sections from the unit that we studied. And what's left is the trig. So I feel like we kind of need to spend a whole another session on the trig. So for now, your assignment is to finish pages 19 through 21, which are essentially problems number 1 through 40. We've done almost a fourth of those together already. And you need to practice several of them to get some sufficient practice in. So that's your assignment for now. Tomorrow we'll come back and get another video over the last half of the study guide. And then I'll be happy to take questions. If you want to email me questions, you can message me questions on Schoology. And then on Monday, the test, again, it's going to be open notes. Use your resources and should be able to do pretty well. Okay, that's enough for now. Hope everybody's feeling okay and been well. I know you're probably tired of being housed up and maybe even ready to come back to school. I'm hoping I can see you guys again soon.